Hello everyone. Today we're going to talk a little bit more about variables in this particular video. So just a little bit more information on how variables work and how they kind of come together. We talked a little bit about variables last week. We're going to get a little bit more in depth into how they kind of function, how we can have like a whole bunch of them together and display everything. So I'm going to go ahead and create my new project. It's going to be a console app, which fortunately saves here. I'll just hit next. And let me go ahead and pull up my magnifier so everybody can see that properly. Now, whatever today's date is, whatever that happens to be, I put the date. And it does need to have the underscores. Generally speaking, it doesn't like to have a number at the lead of a name. And this will just be more variables. Now, as we go through the class, I'll probably do the whole naming thing at the beginning of the video less and less, because hopefully by then you will have gotten used to how this works. But make sure that you've got it saved where you want to save it, and you can change that location. Everything else can kind of leave as is. And I create and we wait patiently while it does its thing. Voila! Alright, so we're here. So I'm just going to erase some of this stuff here. I'm going to just set this up with a few extra comments and whatnot. And of course I can use the naming, the using namespace std to get rid of this if I need to. Well, name space. There we go. And that just means you don't have to add that. So that's what I'm going to do. And that's going to be kind of my default every time we do this. So I don't actually need my hello world here, so I'll get rid of that too. Alright, so we're going to talk about just variables. We talked about integers and floats and doubles and strings and characters and booleans last time. Let's stick with a little bit more math-oriented stuff, because we're always going to have to do a little bit of math. Now, it's kind of a misconception that to do programming you have to be some genius calculus whiz. That's generally not the case, actually. Most programming tends to be in the realm of like just basic algebra for the most part. Now, you could do some calculus stuff if maybe you were building a, physics engine or something for a game or something. You would need calculus and that type of thing. Fortunately, most engines have all that built in, so you don't have to fuss with all the math behind how things work. So, for most of the world, it's just some basic algebra that you're going to need. So, let's just start with our basic, just creating a couple of variables. So I can say int x, and as of right now, you see I've just defined a basic variable. If I want to print it, we can simply do this, and I can just say the variable x is doot x, and we'll run this and see what the output ends up being. If I can remember where, this is the problem with having to, I can just click the button, I guess. That would be a quick and easy way to go. When you're dealing with multiple languages at once. Let's see, the build was successful. Oh, there were build errors. Oh, no, I've got an error. We'll have to figure out what that is. Alright, it crashed. Alright, well, first, let's go down and check. So, I have a variable here, and this is underlined in green. So, should have noticed, there's the error. Using uninitialized memory X. Now, depending on the language you're in, this is allowed or it's not allowed. Obviously, in C++, it doesn't like it. In Java, it would be fine and actually defaults this to 0 automatically. But what it's complaining about here is I don't have any value in there. In C, C++, and those types of languages, it needs to have something there. It has to be initialized. So I can define a variable like this, but I have to put something in it usually. And once I put something in it, then usually it will, be okay. Let's see if it's okay after I put a value in it. Let's see. The variable is 0. There it is, at the very top. So it worked. And I press enter, and it goes away. So as long as I've got it defined as something, then it's usually okay. Now you don't have to define it immediately, but I do have to define it before I actually use it for anything. And you can define multiple ones at once. So I can actually say, you know, x, y, z, for example, in this case, or num1, num2, num3. I usually don't use x, y, and z for my naming, if I can help it. I usually use things like number 1, number 2, number 3. It makes more sense in my head. And it really doesn't matter what you want to call these. I usually tell students when they're writing a program to name it what it is. So in this case, number 1. Now, nothing is set to anything yet, so I'd have to come over here and say, you know, number 1 equals 5 or something. And then I can do something. Number 2 equals 10, and then I can do something. Number 3 equals number 1 plus number 2. So I can make a couple of little adjustments here. And now I have 3 variables that I've declared, and you can declare them all on separate lines if you want to. It doesn't have to be all in one. This is just kind of the more efficient way to do it if you know all the different variables you're going to have. Some people will do what's kind of called stream of consciousness definitions, meaning they only define it when they need it. So if I have a lot of code and they need a variable, they'll define it there, int, you know, here, or double or string or whatever. Bob. So they'll define it as they need it. And there's really not a wrong or right way to do that. Most old school people prefer to have all their variables kind of at the top of the main here. And then you can just use it for the rest of the program. That means the whole project can use all those variables. Whereas here, you know, none of this can use that variable until we get past that spot. But again, there's no right or wrong way. It really depends on how you're trying to put it together. This is one of those examples of everyone's going to program a little differently. And there's always going to be several different ways to do the same thing too. That's why cheating in a programming class, particularly if it's an advanced programming class, is so difficult. I'm not telling you to, that's not a challenge I'm telling you to accept, but it gets a lot harder as you go on because there are so many different ways to do the same thing that it's almost impossible for 2 people to do the exact same thing for some major program, for every single step of it without some sort of them coming together and copying or at least coming up with the same framework. So I've got a couple of variables here. Let's go ahead and go with that double. I'll just call it number 4. Now a double is, again, like a fraction. And of course, I can just print stuff like this. In this case, number 3 plus number 4. So we could just print those together and do the math. Now, the answer, or I should say the question here is, if I make a variable, let's say if I were to say int total equals number 4 plus number 3. And then I try to print the total, just at the bottom here. What happens? One of these is a double, one of these is an int, right? But I'm shoving it into an int, which is smaller than a double. So let's see. Oh, it says I've got some errors. And right here, it actually says specifically the line that I have the error on. In this case, 15. If you look right here, it says line 15. It says number 4 redefinition different basic types. This is one thing you're going to have to learn when you're writing a program, and that's the error messages. What does that mean? What this means here, number 4 is a double, right here, right? And it's complaining, well, let's just double click and see. We'll get a little bit more information about it. Neat. Set C declaration of number 4. All right, it's a double. Is it saying I should make it an int? Because that's not an int there. So if I run it again, run, still, int number 4, redefinition, says the same thing. Basically, it's complaining on this line. Let me go ahead and make that a double again. Let's say I go down here and I just make this a double. So now both of those are doubles. Let's see what if it still gives me the same error. Oh, looks like it is. We got here, the variable is 0. Now, theoretically, I should print the total after that, but it's not. I still have this error here. Number 4, redefinition, different basic types. Now, I'll give you a tip. As we go through the class, you will, of course, run into errors and issues and problems, right? Oh wait, I know what the problem is. And it's totally not what I thought it was. This is actually right here. I've already used number 4. So when it says redefinition, it means in Java, it would tell me that it's already defined. In C++, redefinition means that I've already got it defined once here. So same issue. So let me fix this here. I'm going to readjust. And this also points out, and I'll just leave this in the video instead of redoing it, but no matter how good you are, you're going to screw up sometimes. And in fact, we're going to have a whole video on errors and screw-ups here shortly, because that is just part of programming, screwing things up. So what I'm going to do is I'm going to leave my number 4 there. I'm going to make this number 5. Number 5, there we go. All right. So now we have number 5, and I'm not sure why that's still white, to be perfectly honest, but now we should have an issue on this line, which is what I was originally shooting for, so I didn't realize I misdid some things. Let's see what we got here. All right, so the variable is 15, which that is, and now we've got 18. I guess that's right after that. Probably need to get a new line there, but I'm assuming it's the 18 here. So let's see. We had 15 plus 3.9. So this ends up being, let's just go ahead and do the little math for it. Number 5 is 3.9 plus 15, which equals 18.9. So every little language that you do has different how do I put it? Different rules to certain things. Trying to keep them all straight can be a bit annoying. So let me go up here and just add in a little /n here. See if that makes that look a little prettier. There we go. Oh, and /n, if I haven't covered it already, is a new line. If you add this to the back of a quotation, inside a quotation, it basically is the same as pressing enter. Cout keeps everything on one line, so generally you're going to want to have like some sort of new line. I think there's another one, maybe I'll show you later, like an actual command like inline or something like that. I forget off the top of my head that you can put as well. This is probably shorter though. So all right, so let's see what happened here. We ran my code, and I got 18 for this line here. Now what did it end up being? It was 3.9 plus 15. I got 18.9. One of these is a double, one of these is an int. This is an int. An int, if you remember, is a whole number. So what happens in C++'s case is when I take these numbers together, I get 18.9. And I'm going to shove this into an int. Now an int doesn't have decimal places, and the natural, I guess you can say, inclination for people to think is, oh, it's going to round up to 19. That's not how it works, though. You're trying to shove this bigger number into a smaller place. It's just going to cut off the end number. So this actually ends up being 18 because it cuts off the 0.9 at the end. Now there are functions that will round this up if I wanted to, but otherwise it's just going to cut it off. Now generally speaking, if I have a double and an int and I'm multiplying or adding or something, I would want this to be a double too. So if I make that a double and I run it, if I can click my button, there we go. Now it's 18.9. It actually has the whole thing there. So just a little thing to remember when you're trying to do some of the basic math. Generally, it's better to keep most things doubles. If you just need a whole number, an int's fine. But just note, if you do have an int, you may end up cutting off some decimal places there. And that's usually where, especially when you have to do a little bit of like money math and stuff like that, people might end up having some issues. You get so used to saying int this, int that, int this, that you may just put an int and then lose all the sense of change at the end. Oh, and I should point this out as well. Once you define a variable, which is what these two are, these two lines here are defining a variable. Right down here, I'm assigning values. Now I can assign a value here too, if I want to. Like that. So I'm defining it and assigning a value. But I can also define it and then assign the value after the fact if I want to. Now I don't need the int again, or you'll get that error down there that we saw earlier about redefining a variable. You've already defined it once, you don't have to put the int or the double or whatever again. And you'll see when I click on it, it highlights. If you're using another IDE, the results, the messages may be a little different, but you'll still run into the same problems. Number 3 is these two added together. Now I can add, I can multiply, subtract. So if I haven't gone over that yet, so addition, pretty easy. The plus sign. So it would be like, n1 plus n2. That's what that would be. We have subtraction, which would be the minus sign. And that would be like total equals n1 minus n2. We have multiplication. And this usually confuses some people, but it's the star, not an x, but the star. Total equals n1 star n2. We have division. And that's / here. So it would be total equals n1 divided by n2. And division, you usually have to be a little careful because that could lead to some fractional numbers, some decimal numbers. And if you have int, like let's just say I had, trying to think of a good number that gives me some fractions here. Let's say I take 3 and I divide by 2. Well, 2 will go in there one time, and then there's that kind of 0.5 left over. If I make this all ints, I'll only get the 1. If I make it, a double, I'll get the 0.5. Now there are other ways to do some stuff. There's, I think it's called the caret symbol. I'm not sure if I'm spelling that right, but it's the up sign, this little guy. And that's just like 2 up to 2 is like 2 squared, basically. It takes things up to the power. And the last one is modulus, which is a percentage sign. And it actually kind of does what I just mentioned for division. You have that leftover 0.5, right? The modulus isn't actually a percentage as far as like math is concerned. What it does is it finds the remainder of something. So if I said, for example, let's say 10 percentage 3. That's 10 mod 5 is how that would be pronounced. That actually equals 1. And what ends up happening here is you start with 10, you subtract 3, which gives you 7. You subtract 3, which gives you 4. You subtract 3, which gives you 1. So basically, you divide 3 into it, and you're not really concerned with how many times that goes into it. You're going to subtract a 3 each time. And whatever's left over, that's what this finds. This finds that leftover bit, that 0.5 that we talked about earlier. We're not really going to use this, but this is used in things like encryption and some other stuff. Modular arithmetic, of course. Most of what we cover would generally be in this realm here. But just so you know the different math operators that you get to run into. So that's a quick rundown of just your basic variables and how they work, how we define things and stuff like that. A couple of different ways you can do that, and hopefully all the information on some of the little things. We didn't really cover strings and characters, but we'll deal with numbers a little bit more, and we'll cover more strings and stuff as we move along. So that's it. If you have any questions, feel free to ask me. Otherwise, I'll see you in the next video.